Hello, this is a short presentation of Poisson distribution and Poisson process. Poisson distribution and Poisson process was first introduced by Simon Denis Poisson. This is one of the most widely used counting processes. During World War II, a British statistician, D.R. Clarke, used it and analyzed German bombs which hit in the city of London purely by chance. Poisson was the French mathematician and physicist. He was appointed to the dignity of baron in 1825. In March 1818, he was elected a Fellow of Royalty Society. He proved himself a worthy successor to Pierre Simon Laplace. The following table shows the number of whales observing each day. You only can observe a whale in an hour. What is the probability of observing 14 whales per day? We should use binomial distribution. P equals 14 over 24 equals 7 over 12. The probability of x equals 14 is 14 to 24 times 7 over 12 to 14th power times 5 over 12 to 10th power equals 0.1634. So if two whales were observed in the same times, we should make time units smaller and smaller. When time units approach 0 seconds, the amount of units approach infinities. Limit as n approaches infinity to the quantity of k, choose n times p to the power of k times 1 minus p to the power of n minus k equals lambda to the power of k over k factorial times the limits as n approach infinities to the quantity of n over n times n minus 1 over n times n minus 2 over n, and so on, down to n minus k plus 1 over n, multiplied by the quantity of 1 minus lambda divided by n raised to the power of n minus k. Equals lambda to the power of k over k factorial times e to the power of minus lambda equals lambda to the power of k times e to the power of minus lambda over k factorial. In the Poisson process, the events occur in an interval. If this interval can be partitioned to be small subintervals of the same length such that the probability of having two or more events in the same time subintervals is 0. The probability of having an event in each subinterval is even and proportional to this length. The events occurs are mutually independent. Under Poisson distribution was the expectation of lambda events in a given intervals. The probability of k events in the same interval is lambda to the power of k times e to the power of minus lambda over k factorial. The mean and variance equal lambda. There are also many applications such as photons arriving at the telescope, the number of mutations in a standard of NDA per unit length, each cells using when brewing Genesphere. This table shows the number of soldiers in the Prussian cavalry killed by being kicked by a horse each year in each of 14 cavalry corps over the 20-year period. What is the probability of one death in a time unit? The mean equal 0 times 144 plus 1 times 91 plus 2 times 32 plus 3 times 11 plus 4 times 2 over 144 plus 91 plus 32 plus 11 plus 2 equal 1.071. So lambda equals 1.071 and probability of x equal 1 equals 0.366. This is the last part of presentation. Thanks for listening.